We are going to explore cases like infinity by infinity that we can derive to when we take the limit of some um, rational expressions. So let's see. We have limit x approaches to infinity. We have 3x squared plus 5x minus 1. And we have 2x squared minus 7x plus 5. So since x approaches to infinity, let's plug, see what we are getting. 3 times infinity squared plus 5 times infinity minus 1. Here I have 2 times infinity squared minus 7 times infinity plus 5. So what do we get? In the first case, we have 3 times infinity, which is going to be infinity, plus 5 times infinity. So a squared infinity plus infinity is going to be infinity. So, and minus 1, who cares about minus 1 comparing to infinity? So we get infinity. Next, 2 times infinity squared, it's going to be infinity squared. It's too big of a case. And minus 7 times infinity, it's going to be infinity. So infinity squared minus infinity, we are going to get infinity, right? Same infinity. And plus 5, we don't need to count anymore. So we get infinity over infinity. It's the case we are going to receive. So let's see what we can do with infinity by infinity. So when I have, let's say, 3 over 3, 4 over 4, 7 over 7, it's going to be equal 1, right? And from previous videos also we know that if we divide any number, 4 over infinity, 5 over infinity, 9 over infinity, we are going to get any number divided by infinity, we are getting 0. And if we have all 3 cases, so I'm looking, so when I receive the number by number, I receive number by infinity, or I receive infinity by number. Infinity by 5, infinity by 9. So infinity divided by any number, it's going to be infinity. So if those are cases we can receive. So it's going to be either a value, it's going to be result as a 0, and it's going to be as an infinity. We are going to look at all 3 examples and see what we are going to get there. Okay? Let's see. So, how we are going to approach to the limit of a rational expression when if we plug in the end value of limit, we get infinity by infinity. So one of the methods is limit x approaches to infinity. We are going to define which the highest degree of variable we have. Let's say in numerator it's going to be 2. In denominator also going to be 2. So we will pick the highest degree. It doesn't matter that highest degree is in numerator or in denominator, but in this case we have equal, so it's even easier. So we are going to divide every single term by this x squared. All right? And we are going to get the following. 3x squared divided by this x squared. We are going to divide every single term in numerator and denominator, plus 5x divided by x squared, and then minus 1 divided by x squared. Next, 2x squared divided by x squared minus 7x, 7x divided by x squared, and plus 5 divided by x squared. Okay, so we divided by x squared. What we are going to get here? So first of all, x squared and x squared is gone here. X is gone with x squared. To remind you, when we divide, let's say x, we divide by x squared, what we do, we subtract exponent, right? When we divide the same basis but different exponents, we subtract exponent and keep it where the highest degree in denominator. So 2 minus 1 will be 1, and I am writing down where the 2 is, highest degrees. Now we don't need to write down 1, I'm getting 1 over x, right? So that's why x is gone. Instead of 2, I'm getting 1. And this one, 1 over x, we know that 1 over, right here, number over infinity, it's gonna be 0, right? It's heading to 0. Okay, now second at the bottom, let's see what we get. X squared, it's canceling. 7x divided by x squared, again by same reason, we get x is gone, here is squared is gone, x stays, and 5 over x squared, 5 divided by infinity, it's gonna get 0. So as a result, we are going to get 3 plus 5 over infinity, because here I have x left, right? So if I plug infinity, I'm getting infinity. You know what, let me write one more line with limit, and then we'll figure it out. So limit x, write down clean so it will be clear. So what we have left, we get 3 plus 5 over x, and minus 1 over x squared here, and we get 2 minus 7 over x, and then plus 5 over x squared. So let's plug the values of infinity finally, and we are going to get 3 plus 5 over infinity minus 1 over infinity squared, and here we get 2 minus 7 over infinity plus 5 over infinity squared. Okay, what do we get? We get 5 over infinity, here it is, 5 over infinity, we get 0, right? Number over infinity, we get 0. Minus 1 over infinity squared, even bolder 0, right? Okay, next here we have 2 minus 7 over infinity, it's gonna be 0, and 5 over infinity squared is gonna be 0. So the answer is 3 over 2. Okay, keep that in mind. So moving to next question. Let's see what we're gonna get. All right, So what do we have here? We have limit x approaches to infinity. In numerator we have 5x squared minus 1 and x squared plus 3x. So if we plug infinity, we are going to get 5 times x squared, 5 times infinity squared, right? Squared minus 1 and infinity squared plus 3 times infinity. So we are getting infinity over infinity as a result. All right, so let's simplify now. Let's see what kind of the maximum degree, highest degree has a numerator. It's x squared, right? It has maximum degree. And the bottom also x squared, correct? So let's see how we're gonna work this out. Limit, which means we are going to divide by x squared. The highest degree of the variable. Okay, so limit x approaches to infinity. We divide by x squared everything. Yes, so 5x squared divided by squared minus 1 over x squared. Now here x squared divided by x squared and plus 3x over x squared. What do we get here? Limit x approaches to infinity. So x squared would be cancelled with x squared, right? This one over infinity, if we plug, it's gonna go to 0. This one is also gone, cancelled, and x divided by x squared, x is gone. I don't know what is this from here. So x is gone, and here I will have only squared because degree 1, 2 minus 1, it's going to become 1. And I am getting here 5 minus 0. Well, might as well, since I'm plugging infinity, so let's take it off in limit. So it's going to be, at the bottom, I have x squared over x squared, it's 1, and then plus 3 over infinity, right? So which is going to be also 0. And the result is 5 minus 0, 1 plus 0, and the answer is 5 over 1. Let's look one thing here. We have x squared. We have at the bottom also x squared. When the degrees are equal, the highest degrees are equal, then the result, when in the case of infinity over infinity case, result is going to be coefficient of the, take this color, coefficient of the numerator for the highest degree. We are dividing by coefficient, which is going to be 1, of the highest degree in denominator. So here we get 5, here we get 1. Now going back here, we have x squared. Highest degrees are the same. Therefore, the answer is going to be, if it's x approaching to limit, the infinity, we have the case infinity or the to infinity. That has to be, must be the case. Only in this case, we are getting the answer. See, it's coefficient of highest degree numerator is 3, coefficient of highest degree in denominator is 2. As you can see, the answer we are getting 3 over 2. Okay, which means let's do a couple of practicing problems. If I write down limit x approaches to infinity, if I put let's say 15 x to 6 minus x to squared over x to what? X to 3 plus 14x to power 6. So what is here highest power in numerator? 6. What is highest power in denominator? Also 6. So degrees are the same, which means the answer is going to be coefficient of highest degree numerator is 15. Coefficient of highest degree to highest degree in denominator is 14. And that is for the case when we deal with infinity over infinity. Yes? Let me do this way. Move it this way. Because first we identify that it's infinity. I just already knew it. That's why I put the answer right away. Why? How did I know? Because you have only x's here. X here, x here. So if you plug infinity, infinity, right? Infinity to power 6 minus infinity to power 2, you get infinity. And at the bottom, infinity to power 3 plus infinity to power 6, you get infinity. So for the case of infinity over infinity, when degrees are the same, the limit is going to be the coefficients of these degrees, of these variables with degrees. One more. Limit. Let's say x approaches to infinity. X minus 6 and x, I can put 3x minus 6, 2x plus 5. Okay, let me clean this too. So do we get again infinity over infinity? Yes, because you have 3 times infinity minus 6 is infinity, and then infinity plus 5 is infinity, right? So what do we have here? Highest degree is 1. Here, highest degree is 1. So the limit is going to be 3 over 1, because here you have 3 and here you have only 1. So it's going to be 3 over 1. One more to do better. I have limit x approaches to infinity. If I have, what do I have? 5x cubed plus 2, and I have x squared plus 4x cubed. Okay, looking at it, do we have here x cubed, the highest degree? X cubed, we have highest degree? Yes. And if we plug infinity, we are going to get infinity over infinity, yes? Okay, so from here, we are getting 5 over 4, because this is your 5 and this is your 4. Here we have coefficient 3, coefficient 1. Here we have coefficient 15 and coefficient 14. And that's how we get the answer. Okay, so what we are going to remember, summarize from this case. When you have case infinity over infinity, you are going to plug infinity and see that confirm that you are getting combination infinity over infinity. And if the degrees are highest degrees and numerator and denominator is the same, then limit it's gonna be the fraction of this coefficient of numerator and coefficient of highest degree in denominator. Okay, now let's take the case when they are not equal. The highest degree of variables in numerator denominator are not equal. What we are going to get in that case? Okay, let's assume I have limit x approaches to infinity, and we have 4x plus 1, and in denominator let's say we have x cube plus 5. So if I plug, I'm still getting infinity over infinity, right? Because infinity plus 1, infinity cube plus 5, we get infinity over infinity. So how we are solving? Again, we divide by highest degree. What is going to be highest degree? X cube, correct? So I'm dividing 4x, the entire fraction I'm dividing by x cube, because x cube is the highest one, because on numerator I have 1, so cube is higher, plus 1 over x cube, and then in denominator I have x cube divided by x cube, and then plus I have 5 over x cube, right? So what do we get here? This x is gone. This was 1. This 3 will become 2, right? Because 3 minus 1 is 2. 1 over x cube I'm not touching. Oops, I forgot to keep here infinity, limit for, with x is running to infinity, because I haven't plugged it there yet. Okay, so here in denominator is gone, x cube, and we have 5 over x cube. So the result is, it's going to be, let me rewrite clean, limit x approaches to infinity, 4 over x squared plus 1 over x cube. Here we have 1 plus 5 over x cube. So what do we get? I get 4 over infinity plus 1 over infinity cubed. Okay, infinity squared. At the bottom I get 1 plus 5 over infinity cubed. So result is 4 over infinity, it's 0. 1 over infinity cubed is also 0. Here I have 1 plus 5 over infinity cubed is 0. So the answer is going to be 0 over 1. The answer is 0. And believe me, trust me, I know what I'm saying. Based on one example, I could solve again another example to show you. But the bottom line is, if the highest degree in denominator, which is 3, greater than highest degree in numerator, then, and the limit gives you infinity over infinity case, then the final result for such infinity, for such limit is 0. Okay? Then a final, the result for limit is 0. One more time. If the highest degree of denominator is greater than highest degree in numerator, and you are getting the case infinity over infinity, then the limit of such rational expression is going to be 0. And let me solve another case. So we showed that, remember at the beginning, I showed that a result when x approaches to infinity, we can have either number, we can get 0, we can get infinity. We got number, right? We got 3 over 2, here it is. Now we got 0, where it is here, here it is, we got 0. Now it's I need to show that we can get also infinity. How do we figure it out? So example, limit x approaches to infinity, and you have here x to 5 plus 3x. Okay, you know what, let me solve another example with that 0 so it will be clear. Since I have here x to 5, well, let me see, as long as I have to take any x with a degree higher than 5. Okay, let me take 6 plus 2x squared. Highest degree is 6. So yet again, when we have highest degree here greater than highest degree numerator, when we are going to get 0. Well, let's check it real quick. So if I plug infinity, infinity here, infinity, I'm getting infinity over infinity case, right? So from here I'm going to get, I'm going to divide by highest degree, which is going to be x to 6, x to 5 divided by x to 6, plus 3x divided by x to 6 over x to 6 divided by x to 6, and plus 2x squared divided by x to 6. So what do we get? X to 5 is gone. 6 will be about gone, so we get 1 over 6. Why? One more time, x to 5 divided by x to 6. We need to subtract, right? And leave the exponent where the biggest one is. So biggest one is 6 at the bottom, so 6 minus 5 is 1, so I leave here 1. So x to 5 is gone, so it will be 1. So the answer, it's going to be here, limit x approaches to 0, I mean infinity. I'm getting 1 over x. Next, 3x over x to 6. This x is gone. So instead of 6, I have 5, because 6 minus 1 is 5. So it's going to be plus 3 over x to power 5. Now denominator, x to 6 gone with x to 6, we are getting 1. And x to square is gone with x to 6. It's going to be 4, because 6 minus 2 is 4. So we are getting plus 2 over x to 4. And what is the result if I plug? I'm plugging 1 over infinity plus 3 over infinity to power 5. Here I have 1 plus 2 over infinity to power 4. So I get 0 plus 0, 1 plus 4 plus 0. And the answer is 0 over 1, which is 0. All right? So another example that shows if the degree in denominator is greater than the highest degree in numerator, and you get format infinity over infinity, then your limit is gonna be 0. Now let's solve the cases when the limit is gonna be infinity. Okay? So I have limit x running to infinity. I'll tell you what, this every time let me change the color so you would know when we get number. Where is it? Well, I can take into rectangle so you can see it's a 0. Here I get the answer 5 over 4, 3 over 1, 15 over 14, and here 5 over 1. Okay, and 3 over 2, we already have it. Okay, so I took in the frame, so you will see where we have the answer. I'm trying to add some space. So for the readability purpose, oops. Oh yeah, that's the same problem here. Bring down this one, okay, and then move this one down. All right, move this one down. That's the same thing, and this is also same thing. Okay, we are good. So we have x approaches to infinity, 3x to power 4 plus x, 2x to power 2 minus 4. So we look the cases when highest degree numerator denominator are equal, then we are getting the coefficient from the highest degree numerator and coefficient for the highest degree in denominator. When we have highest the degree in the numerator, then the limit is becoming 0. Now let's look when highest degree in numerator. What is gonna happen? We are getting infinity over infinity, which if I solve it, I'm going to get, again, I'm dividing using the same method, which means dividing by highest degree. So highest degree is going to be x to 4. So let me divide. It's going to be 3x to 4 divided by x to 4 plus x divided by x to 4, 2x squared divided by x to 4, and minus 4 divided by x to 4. And what do we get? X to 4 is gone with x to 4. Here I will have x would be gone. Instead of 4 I will have 3 because this is 1. 4 minus 1 is 3. Here x squared is gone, and instead of 4 I'm getting 2 because 4 minus 2 is 2. And 4, okay, I rushed ahead. It's supposed to be x to power 4. Okay, so let's write down what we get. Write down clean. Limit x approaching to the infinity, and we get 3 over oh, we have only 3 there. Very good. We are getting only 3, and then plus we are getting 1 over x cubed, and then we have 2 over x squared, and here we have 4 over x to power 4. And what we're gonna get, if we plug infinity, we are going to get 3 plus 1 over infinity, it's gonna be 0. At the bottom, we have what? 2 to power x squared, meaning 2 divided by x squared, which is 2 divided by infinity, right? We get 0. And 4 divided by infinity here will be 0. And result is 3 over 0, which is gonna be infinity. Number by 0 is infinity. Yes? So let's solve one more example. All right, so limit x approaches to infinity, and what do we have? Let's say 5x cube plus 3x and over x squared plus 19. So since we have infinity, you can you already know, since the degree of the numerator is greater than degree in denominator. So, and we have infinity over infinity. Yes, absolutely. Therefore, if that is the case, the result is gonna be infinity, because numerator in highest in at the numerator has greater degree than denominator. So result is gonna be infinity. One thing is interesting, that this method, not method, but result, type of result, it's very similar to horizontal asymptote. That's the same way we would identify about horizontal asymptote. If degrees are the same, then horizontal asymptote would be equal coefficient of highest degree in numerator divided by coefficient of the highest degree in denominator. If the rational expression has degree in numerator greater than in denominator, then there is no horizontal asymptote, because it's infinity, obviously. And in the case of when highest degree in denominator is greater than highest degree in numerator, then your horizontal asymptote is equal 0. It's absolute similarity to that. Okay, and also, what important summary you can conclude: every time when you get infinity over infinity, all you have to do, divide numerator and denominator by the highest exponent. Okay, thanks for watching, and my next video will come format of 0 over 0.